am going to discuss about the topic sets. I am going to discuss all these topics. First, let us start with the definition. Any collection of well-defined object is called a set. What do you mean by well-defined object? Here you have to give importance for well-defined. By this time you all know what do you mean by well-defined. Well-defined means what you have to observe is, see, few examples I want to give. Set of natural numbers, set of integers, the collection of 10 writers in India, the collection of singers in India, all these comes under the sets. Here well-defined means whoever wants to talk about that particular statement, for everyone that objects in the sets will be same, then you call it as well-defined, then that is called as set. Any object in the set is called as its element or member of the set. Usually sets are denoted by capital letters and its elements are denoted by small letters. Totally a set is denoted like this, A, B, C. We'll go for representation of the set. There are two kinds of representation. One is roster method, another one is set builder method. Set builder method or set builder form. Roster method means here we are going to list every element of the set. That is, for example, A is equal to 2, 4, 6, 8, 10. That is, you are going to list every element of the set. Set builder form means we are not interested in listing the elements. We write here the special property or some rule which every element obey that. For example, here I can give for example, A is equal to set of even numbers less than 10, or else I can write like this. X is such that, or set builder method we write like this. X is such that X is an even prime number. See, here I am not telling which is the set. I am telling the property for which the elements are going to follow. When we come to roster method, here, see here order is not important. In roster method, order is not important. If you want, you can write the same set as 4, 10, 8, 6, 2. It's your wish, whichever might be the first element, whichever might be the second element. And also, an element is written only one time. There is no need to go for repetition of the element. Okay, next thing is, we'll go for different types of sets. First, let me talk about empty set. What do you mean by empty set? If a set does not contain any element, then we call it as empty set. A set does not contain any element. Does not contain any element means, for example, I'll give an example like this. Set is like this. X is such that x square minus 2 is equal to 0. X is natural number. See here what I have written. X square minus 2 is equal to 0. If you solve this, it will be like this. X square minus 2 is equal to 0. X square is equal to 2. And x is equal to plus or minus root 2. But what is there here? X is a natural number. When x is natural number, either root 2 is not a natural number or minus root 2 is not a natural number. Therefore, A is equal to empty set. Empty set can also be denoted by this symbol or it can also be denoted by this symbol. Also, empty set can also be called as void set or else null set. So, empty set, void set and null set. All the three names are given for the same set and its symbol is like this or like this. The next one is singleton set. Singleton set means set contains only one element. Set contains only one element. Look here carefully. I'll write one example. A is equal to 0. Why I have written 0 only instead of writing any other number? Don't get confused this as empty set. See, 0 is element. I have written one element there, no? So, one element is there. That's why I have shown this symbol also. See here, I have not written any element. Like this is there means it is empty set. This is not empty set. This is singleton set. Whereas this also, if I write like this, it is obviously it is a singleton set. If I write like this is also singleton set. Don't take here this as symbol of empty set, nothing like that. So this is also singleton set. Finite set. Finite set means, see now you know, set means you are going to list some of the elements in that. Counting of the elements in the set certainly comes to an end, then it is finite. Otherwise it is infinite. That means what? Consistency, I mean, if the numbers are consistent, you call it as finite set. If the numbers are not consistent, then you call it as infinite set. We'll go for cardinal number of a finite set. Cardinal number of a finite set. Suppose A is equal to, I am going to write this. Here I can write, let me count how many cardinal number. Cardinal number means, with example I want to explain this. Consider a set A, B, C, D. I want to take like this. See here, I have written a set here. See A, B, C, D, 4 numbers are there. I have written n of A is equal to 4. This is the cardinal number. That is nothing but number of elements in the set is called as cardinal number. We'll go for equal sets. We call sets are equal. Let me take set A and set B. We call A, B are equal sets. If every element of A is an element of B and every element of B is an element of A, that is, if A is, every element of A is the element of B and every element of B is the element of A, then we call that these two are equal sets. Next concept is equivalent sets. Okay, see here, equal, equivalent, both are different. Equivalent sets means if the cardinal number of two sets are same, then we call it as equivalent set. Suppose A is equal to 1, 2, 3, 4. B is equal to X, Y, Z, A. Then we say that A and B are equivalent sets because cardinal number of A is equal to cardinal number of B. It is represented by this symbol. This is nothing but A is equivalent to B. That is, number of elements in A is equal to number of elements in B. Next is subset. Subset can't be discussed individually. We'll take subset and superset together. Subset and superset. Subset, superset. A is equal to, I want to take this, P is equal to X, Y, P, Z, A, L, B, C, M, B. Okay, see here, A contains these many elements, B contain these elements. Now, every element of A is element of B. Can you see? A, B, C. So, we say A is subset of B. This is the symbol for subset. The same thing can be read as B is superset of A. A is subset of B. B is superset of A, which can be written like this. A is subset of B. B is superset of A. If every element of A is the element of B, then we say A is subset of B. At the same time, B is called superset of A. Here, I want to discuss one thing, that is proper subset. Proper subset. What do you mean by proper subset? Again, I want to give example. Like this is A and I want to write C is equal to ABC. You can see here A is equal to C because you see every elements are same. Every elements are same. Therefore, I can say A is equal to C. Also can be written as this. When, see here, observe carefully, this symbol is there. It is denoted for proper subset, whereas this denoted as subset. What is the difference? What is the difference? See, equal set can also become a subset. That is what I will tell three important things. Every set is subset of itself, but every set cannot be proper subset of itself. That is proper subset. If you want to say proper subset means at least one element should be extra in the superset. Then you call it as proper subset. Otherwise, not proper subset. So every set is subset of itself. Null set or empty set is subset of every set. And how many number of subsets are possible for a set? I want to tell that. How many number of subsets are possible for a set? Okay. So if number of subsets is equal to, it is given by the formula 2 to the power n, where n is number of elements in the set. So first thing is every set is subset of itself. Every set is subset of itself. Second thing is empty set is subset of every set. Third thing is number of subsets is given by the formula 2 to the power n. Then definitely number of proper subset formula will be 2 to the power n minus 1. Number of proper subset formula will be 2 to the power n minus 1. Next, let me take universal set. Universal set. What do you mean by universal set? Is suppose we are talking about numbers. Let me think. We are talking about numbers. So you can talk about natural numbers. You can talk about integers, rational numbers, any kind of numbers you are talking about. See, you know already all these are subset of real number. All these are subset of real number. Here, this real number is called as universal set and it is denoted by this letter, capital U. It is denoted like this. This is nothing but universal set. That means it is superset of all the given sets. We'll go for operation on. Now let us take operations on set. Let me take first one as union of sets. Let A is equal to 1, 2, 3. The set B is equal to 3, 4, 5. Union of set is defined as A union B is equal to X such that X belongs to A or X belongs to B. For this example, A union B is equal to X belongs to A is there. So take the elements of A. In A you have 1, 2, 3. I have written that. Next X belongs to B. X belongs to B. It starts with 3. No need to repeat it because we won't repeat the elements in the set. So I will write it as 3, 4, 5. So A union B is 1, 2, 3, 4, 5. That's about union. These can be represented in Venn diagram. I will tell what you mean by Venn diagram. To represent universal set, we show a rectangular box. And to represent sets, we are going to write small circles in this. Like this you can represent Venn diagram. Here it will be universal set. This is A, this is B. Any number of subsets are there means you can show it as circles. For union, you can show it in Venn diagram. And I want to show that in Venn diagram like this. This is the Venn diagram for this. Let this is set A and this is set B. This is inside only, you have to write. This is A, this is B, this is union. In A what you have? 1, 2. See, this 3 is there in both. Therefore, that 3 must come in this part. This is the part which is common for A as well as B. 4, 5. So, union is represented as the shaded region shows you union of two sets. Second one is intersection of two sets. The next one is intersection. For intersection, definition is A intersection B is equal to X such that X belongs to A and X belongs to B. Remember, union I have written OR. For intersection I am going to write AND. Yeah, the same example I want to take. Okay. A intersection B is equal to, see, X belongs to A and X belongs to B. X must be there in both the sets simultaneously. Therefore, or else I can say common element of both the sets. So, common element is only one, that is 3. This is intersection. How to represent it in Venn diagram? In Venn diagram, intersection is represented like this. So, this is intersection. Let me go for disjoint sets. Third one, disjoint sets. See, disjoint sets is nothing but there won't be any common element for the sets. That is, A intersection B is equal to null set. If A intersection B is equal to empty set, then we say that A and B are disjoint sets. Example, A is equal to 1, 2, 3. B is equal to ABC. How to represent it in Venn diagram? So this is A, this is B. 1, 2, 3, A, B, C. This is set A, B and this is universal set. So disjoint means there is no common element. See, there is no, so I can't show you the intersecting part. Next is difference. Next one is difference of sets. Difference. So difference is denoted by this. A minus B is defined as X such that X belongs to A and X does not belongs to B. X must be there only in A. Example, A is equal to 1, 2, 3. B is equal to 3, 4, 5. A minus B is equal to 1, 2. You can't take 3. See here, X belongs to A and X does not belongs to B. See, 3 is there both in AB, so you can't take. That is difference. If you want to write B minus A, see 3 is there here, so don't take that. 4, 5. This is B minus A. You want to represent it in Venn diagram means that will be like this. This is A, this is B. 3, 1, 2, 4, 5. Okay. Look here. This part is A minus B. This part is B minus A. This is set A, set B, units. Symmetric difference. Symmetric difference. What is this? Symmetric difference is defined as symmetric difference between A and B is equal to A minus B union B minus A. Symmetric difference is defined as A minus B union B minus A. That is, you have to remove common elements and you have to write. So, the same example. Symmetric difference is A minus B. A minus B means 1, 2. Union means, you have to write all the elements. So that is 4, 5. This is symmetric difference. We'll go for complement of a set. Complement of a set. If A is a set, then its complement is denoted as A dash. And the definition goes like this. Complement of a set is given by, that is A dash is equal to X such that X does not belongs to A and X belongs to U. X does not belongs to A and X belongs to U. Some rules or some laws are there on complement of a set. They are always U complement is null set. U complement means what? Every element will be there in U. Complement means what? The element which is not there in universal set you have to tell, that is nothing but null set. And null set complement is nothing but U. And if you apply the complement twice, that is A complement whole complement is equal to A. A intersection A complement is equal to null set. And A union A complement is equal to universal set. Let's discuss laws of algebra of sets. We have idempotent law, identity law, commutative law, associative law, distributive law and De Morgan's law. Let me tell you what are these laws. First is idempotent law. And idempotent law says A union A is equal to A intersection A is equal to A. A union A is equal to A intersection A is equal to A is idempotent law. Second one is identity law. Identity law is A union null set is equal to A intersection universal set is equal to A. This is identity law. Commutative law says A union B is equal to B union A and A intersection B is equal to B intersection A. Associative law goes like this. Associative law is A union B union C is equal to A union B union C. And A intersection B intersection C is equal to A intersection B intersection C. This is commutative law and this is associative law. Next we have distributive law. We have distributive law. So distributive law is A union B intersection C is equal to A union B intersection A union C. See here, A union B intersection C is equal to A union B intersection A union C. Similarly, one more is there, that is A intersection B union C is equal to A intersection B union A intersection C. Last one, that is De Morgan's law. De Morgan's law is A union B whole complement is equal to A complement intersection B complement, and A intersection B whole complement is equal to A complement union B complement. These are most important for us. You can keep star mark because while solving sums, these are very, very important for us. These laws, you have to keep it in memory. We use this when we are going to solve sums. So you have to remember idempotent law, identity law, commutative law, associative law, distributive law and De Morgan's law. Some problems. See, first question itself is on definition. It is very, 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 very important. Be careful of definition. Definition will mislead you that whether it is null set or it is not a set. Look at this sum. The set of intelligent students in a class is. The set of intelligent students in a class is. And options are null set. You want to tell null set? No. A singleton set, finite set, not a well-defined set. Now you come to know now what do you mean by well-defined. Therefore, for this answer is not a well-defined set. Look at the second one. The set A is equal to X. X is belongs to R. X square is equal to 16 and 2x is equal to 6. Look at this and. Whenever and comes, it is intersection. That means elements must follow this condition as well as this condition. What is the condition here? X square is equal to 16. We all know x square is equal to 16 implies x is equal to plus or minus 4. 2x is equal to 6. See, 2x is equal to 6. X is equal to 3. So, our set must be 4 minus 4, 3. Our answer is 4 minus 4, 3. Do we have that? See, first option is null set. Second option is 14. See here, and is there. And is there means first thing. See here, if it is OR, we should follow this. If it is union, we should follow this. And is there. Plus or minus 4 and x is equal to 3. There is no common point at all. Therefore, it is going to become a null set. No need to go for further options also. Look at the third one. The number of proper subsets of the set. Proper subsets of the set 1, 2, 3. Proper subset means what? The set itself can't be proper subset. Remaining all are proper subsets. How many number of subsets will be there? 2 to the power n. Here in place of n you have to substitute 3. Therefore it will become 2 cube. We all know 2 cube is equal to 8. For proper subset, what is the formula? 2 to the power n minus 1. 2 to the power n is 8. 8 minus 1 is 7. So the number of proper subset for this set or any set having 3 elements would be 7. Look at the fourth one. If A and B are any two given sets, A and B are any two given sets, then A intersection B whole complement is. We need to solve this. Look here, just now we discussed some of the laws. In that, see this? This follows De Morgan's law. Let me split this first. See here, A intersection B whole complement is nothing but A complement union B complement. Now it is just distributive law. Apply distributive law here. This is nothing but A intersection A complement union A intersection B complement. We all know A intersection A complement is nothing but null set. There is no common element at all between a set and its complement. While telling complement, I told about this union A intersection B complement. If you take union of a set with a null set, your resultant would be A intersection B complement. That is option D. Fifth one. If A and B are two sets, then A intersection A union B is. It can be solved in two ways. Just look here. Fifth I am talking about. See here, I want to apply distributive law. If I apply distributive law, you see here, A intersection A intersection A union A intersection B. Okay. A intersection A is A itself. A intersection A is A itself union A intersection B. Look here, what is going to come? It looks like unsolved. It looks like unsolved. See, look at the options. A, B, null set, none. Like this it is there. But to avoid your confusion, I will show you one thing. By looking at this, easily you can go, this is equal to A. Because, look here, A intersection B means what will be there? Common elements of A and B will be there. Along with that, you have to take A. So, it will become A. Or else, to avoid your confusion, I will tell this also. I want to show you the Venn diagram. This is A, this is B. Okay, look at the question. This is A, this is B. First of all, solve this. A union B. A union B means what is there? Complete this now. A union B means what? Complete this is your A union B. Shaded part is your A union B. What they are asking? A union B. Complete this A union B along with, see here, A intersection this much. Where is A? This is A. This is A. Okay. So, this is our answer. What is our answer? This one. A is our answer. So, your correct option is option 1. Option A. Sixth question. If A is equal to the set, null set, set of null set, then power set of A is. What do you mean by power set? Power set is the collection of subsets of a set is called as power set. Collection of subsets of a set. One example I will give here. Suppose A is equal to 1. A is equal to 1. The collection of all the subsets, that is P of A, power set is equal to, we know no? Null set is subset of every set. Therefore, this will come. The set itself is subset. Therefore, this will come. Nothing else. And also you can go for the formula also. What is the formula known to you? Number of subset is equal to 2 to the power n. It is 2 to the power number of element you have only 1. 2 to the power 1 is equal to 2. Therefore you will get only 2 subsets. Its collection is nothing but power set. Now come to the original question. What they are asking? If A is equal to this null set, set of null set. How many elements are there? 1, 2. How many elements are there? 2 elements are there. Then in the power set, how many elements should come? I will write n of A. In the power set, how many should come? 2 to the power 2. 2 to the power 2 means what? How much? 4. Whichever the option will contain 4 elements, that is our answer. Look here, option A is only A. No. Option B, you have 1, 2, 3. No. Option C, you see, null set. Because null set is subset of every set. For this they have written set of null set. And for this, set of set and the whole set itself. Therefore, this is our correct answer. Seventh one. Which of the following has only one subset? Only one subset. Only one subset means what will be the formula? 2 power 0. 0 means what? There must not be any element in the set. Then definitely it is an empty set. How many subsets will be there for this? Number of element is 1, 2 subsets because 2 power 1. Same explanation for this. If the element is 1 or 4, what is the difference? Number of element matter for us. For this, 2 elements are there. Therefore, number of subsets formula will be 2 square, that is 4. Look at the 8th question. For any 2 sets A and B, A minus of A minus B. For any 2 sets A and B, A minus of A minus B. First thing is, look here. This part you call as A minus B, correct? This part you call it as A minus B in the Venn diagram. Remember Venn diagram I have told. So if it is A and B, this part you call it as A minus B. Now they are asking you about this total A minus B. That means what? You should remove this. You should remove this A minus B. See, this total A minus of this. If you remove all this, what is left with you? You are left with this part. That is nothing but A intersection B. So, our answer is A intersection B. See, to solve such problems, I would like to give you a note. See, note this. Such problems are easy to solve through Venn diagram. Therefore, only I am telling you about this. See here. Let this is set A and this is set B. Assume you have only 2 sets given. You have given only 2 sets. What do you call for this part? This part is called as A intersection B. What do you call for this part? This part. Okay. See here. First of all, it is only A. See here. Little careful. This is complete A. This part is A intersection B. If you join these two, then it is full A. This blue shaded region is only A. And now you see, this is only A. Only A can also be written as A minus B. Also, if only 2 sets are given, this part can also be written as B dash. Same thing I can go for this part. This part also same discussion I can say. This is only B, or else it is B minus A, or else it is A dash. This is very, very important note for you. This is a note for you. In the note you take second point, you will come across some of the practical problems. Already you know what do you mean by practical problems. For example, so many students will take tea, so many students will take coffee. What you want to take? I want to take apple juice. What about you? See here. First question, n of A union B is equal to n of A plus n of B minus n of A intersection B. Second thing is n of A intersection B is equal to, very simple. If you take this if you take to this side LHS and this if you take to RHS, that's all will be the second formula. That is n of A intersection B is equal to n of A plus n of B minus n of A union B. Third one is there, the bigger one. If you have 3 sets, A, B, C. So give me few seconds. It is little bigger, no? That's why. Give me few seconds. Okay. So the third one, n of A union B union C is equal to n of A plus n of B plus n of C minus of n of A intersection B, n of B intersection C, plus n of C intersection A, plus n of A intersection B intersection C. These are important three formulas for practical problems which I want to discuss now. If n of A is equal to 115, n of B is equal to 326, n of A minus B is equal to 47, then n of A union B is equal to how much? See here, we have practical formula for union intersection. Here minus is there. So what I want to do is, let me go for Venn diagram. This is A, this is B. See, n of A intersection B is nothing but only A. We know that. So let us fill this. This is 47. They have given n of A. N of A means complete this. This total is 115 and this part is 47. So this part, that is A intersection B, will be this minus this, that is total minus this much. So 115 minus 47. So it is 15 minus 7 is nothing but 8. 10 minus 4 is nothing but 6. Now see, n of B they have given. N of B is nothing but 326. Out of 326, 68 you have filled already. Since you have filled already 68, out of 326, remove 68, that is 16 minus 8 is 8, 11 minus 6 is 5, and here it is 2. And their question is n of A union B. N of A union B means this plus this plus this. So let me check unit place first, because you see here how much it is. 8 plus 8 is 16. 16 plus 7 is 23. Your unit place is filled by 3. Look at the options. Here you have 3. No other option is having 3 in the unit place. Don't add completely. That will be your answer. If you want for your satisfaction means go ahead. Look at the next sum. 10th question is the universal set, that is n of U is equal to 700, n of A is 200, n of B is 300, n of A intersection B is 100, then n of A complement intersection B complement. Think, what is this? A complement intersection B complement is nothing but n of A union B whole complement. You know how to solve A union B. For n of A union B, you need to apply n of A plus n of B minus n of A intersection B. Or else for this, formula is n of U minus n of A union B. Solve this n of A union B. N of A union B means what? 200 plus 300 minus 100. So 200 plus 300 is 500. 500 minus 100 is 400. N of U is equal to 700 minus 400, which is nothing but 300. So our answer is 300. Like this, you are going to solve practical problems. For our KCET, you are going to get 1 mark from the sets. See, sets is very easy topic. Give concentration towards this. It take less time and definitely it is going to give 1 mark for you. All the very best.